All right, in this problem we've got a cubic function, and we want to show that for every point that this slope is always going to be positive, that in this function the slopes are always positive or zero, never negative. So the first step is we're going to find the derivative of the function. That's going to give us a formula for all the slopes, and then we're going to take that formula and we're going to make it greater than or equal to zero. It should be, because it's got to be positive. So let's start with the original. 3x to the third minus 3x squared plus x minus 7. We're going to use the power rule to find the derivative, which means we're going to bring each exponent, multiply it by the coefficient, and lower the exponent by 1. That gives us 9x squared minus 6x plus 1. Now we're going to make this greater than or equal to 0. See if I do this right. Yeah, I do. And this is a quadratic inequality. So what we're going to do is we're going to find the x-intercepts, and then we're going to graph them, and then we're going to use that to solve our equation, or inequality. In this case, you'll notice that there is only one x-intercept. That's 1/3. So basically what's happening is that this quadratic is going to touch the x-axis at 1/3, and only at 1/3. At 1/3, so what I'm going to do now is I'm going to check outside point, just like I would have otherwise. And if I plug a 0 in there, I'm going to find out that whenever I plug an outside point in, it's going to be greater than 0. So that's true. And then if I take 1/3 and plug it in, I'm going to find out that it's going to equal 0, which makes only sense because it's an x-intercept, and x-intercepts are when y equals 0. So basically what we've done here is we have proven that for every value of x, this formula is going to come up with a positive or a 0 slope, which means that the formula that it came from, the original function, must have all positive or 0 slopes. Now don't be confused, because clearly a quadratic is not going to have all positive slopes, but that's not what we're talking about. We're talking about the original function. The original function looks like this. And as I go up, it's positive, now it's 0, and it's still positive. In the original function, it's always going to be either a positive or a 0 slope. And so that's why it's true. All right, thanks for watching.